All right, I think we can get started slowly. I still see a lot of people trickling in, but hopefully that will die down in a minute. A reminder again, this meeting is recorded. It'll be on the GOOS website. We hopefully will get that up straight away in the next couple of days so you can get the information that we're sharing today, including the presentation and any relevant links. Just as a quick reminder, I will drop the link to the GOOS webinar series in the chat in a moment. We're currently updating the links to be the YouTube links instead of the Google Drive links because it's causing some access issues. So just give us a day or two to adjust that. And then everything should be updated. We're also sending out a survey again afterwards to capture whether people enjoyed the topic, if they needed a follow-up webinar on the specific topic, and capture some of your requests for upcoming webinars. We already have some that are being pulled together, so keep an eye out. We have some planned for the next 3 months already. And yeah, I think I'm just gonna hand it over to Kara to get started. And please put any questions in the Q&A section so we can track them and then answer them after Kara's done.
Great, thank you. I will share my screen. Can you see my screen okay?
Yes.
Okay, great, thank you. So today I'm going to talk about how to access ERDDAP data using R. I am at the Southwest Fisheries Science Center in Monterey, California, and I'm also the PI of the West Coast node of Coast Watch and Polar Watch, and a lot of the materials I'm going to show today were actually developed as part of the Coast Watch training courses that we've done that help people access satellite data. And the Coast Watch heavily uses ERDDAP, so a lot of it is ERDDAP resources. Why is this not advancing? Here we go. Okay, this is strange. Okay, there we go. This is part of the GOOS ERDDAP Seminar Series. This is the 4th seminar. As was mentioned, the previous seminars have been recorded and can be seen on the seminar webpage. So given that, I'm assuming that people are familiar with ERDDAP, so I'm really not going to give an introduction to ERDDAP since that's already been done in previous presentations. And so this is just showing you the schedule, what the ones we've had and the ones that are coming up. This seminar came up, actually, the idea for this after the seminar that was given in October, where Calum was showing how to use ERDDAP using Python, and there was a request to show how to do it in R. So this is sort of the follow-up to that one in October using R. And actually, we're going to show some of the code that he showed. Roy Mendelson has converted into R, and so we'll be showing some of that exact same code here. Having difficulty advancing here. Why does this? This is very strange. I'm sorry, I'm having technical difficulties here. Why does it not want to advance?
If you unshare and then share again, and maybe just there we go. Maybe it's just lagging. That sometimes happens.
Oh, wait a minute. Are you still seeing my screen?
Yes.
Really, I'm not. Oh, where did it go? I'm sorry, this is weird. When we tested this was okay. All right, so you're seeing the Rollo scripts slide now, yes. Slide 3? Okay, great. Sorry about that. So as I mentioned, Roy took the Python scripts that Calum showed in October, and he converted them into R. So if you're interested in that, you can go to his GitHub name at R Mendels, and all of the scripts are there. And actually, some of this I'm gonna show in the first bit today. Great, now it's advancing, great. All of the presentation material that I'm giving today is also available on GitHub. So if you go to GitHub CoastWatch Training Workshops, there is both the presentation, so that's the slides I'm showing here. I'm going to be showing today scripts and R code in the presentation. Personally, I find that when I've seen people show code, do code demos online, it whips through really fast. The font is like size 8 and I can't read it, and my eyes glaze over. So I'm actually not going to show the code in, being run in RStudio. If there's time and interest at the end, I can do that. But all of the code that I'm showing in the presentation is in an R Markdown that's also on this GitHub. So you can get all of it. So don't feel like you have to, do mad copy pasting from the PowerPoint. It is available in a Markdown file. Okay. So basically what I'm going to be talking about today is if you're interested in getting ERDDAP data from R, there's 3 packages that are incredibly helpful that you need to use. The first one is called ERDDAP. This is a general purpose R client for ERDDAP servers. It has 4 key functions in it. Info basically just gets sort of the basic information about an ERDDAP data set. There is ed _search, which is a way to search for data sets on ERDDAPs, on any ERDDAPs, whether it's TableDAP or GridDAP. And then TableDAP and GridDAP get either TableDAP data, tabular data from ERDDAP, or gridded data from ERDDAP. And then the other 2 packages are PlotDAP and ERDDAP Extracto. And these were functions that have been developed by Roy Mendelson at my lab. And a lot of these, the uses for this, a lot of them came out of working with our users and working with users in the CoastWatch satellite classes. They focus on getting gridded data sets, but they also use the ERDDAP package. So you, to get data from about the data, the ERDDAP data sets using the info package. But then, so PlotDAP basically visualizes the ERDDAP data, so it visualizes gridded data. And then it also has some extra functions to add data to the maps that it creates. So PlotDAP is sort of a nice way to make a quick and easy plot. Different than using, basic functions or gplot. And then our ERDDAP Extracto, there's 3 key functions that are part of our ERDDAP Extracto. It was initially developed for helping our users who have tagged animals, so basically tagged animal or a ship, something that's moving in latitude and longitude and time. So you have an X, a Y, and a T, and you want to get the satellite data or a gridded data set that matches up with those points. And so that's what the primary function in this package does. That's the R Extracto. So you basically, user supplies a vector of X, Y, and T, and then the function goes and gets the satellite data that the user requests associated with those points. The other functions that it does is it gets data in a 3-dimensional box. This is basically the same thing that you can get from GridDAP, but it returns the data in a slightly different format, and I'll be talking about that. And then our Extractagon is basically also gets a 3-dimensional sort of cube of data, but instead of being a box, it's in an irregular shape. So think maybe you have a marine sanctuary, or you have an oddly shaped, fishing area, something in the ocean that's not a box, and you want the data around that. So it basically will return a polygon of data for you. And then there are 2 plotting functions associated with our ERDDAP Extracto: plot bbox, which plots the result of either our Extracto 3D or the R Extractagon, and then plot track plots the results of the R Extracto. And so basically what I'm going to do in the next half hour or so is walk through some examples of all of these. So first we'll look at we'll start with the ED search package. That's an R ERDDAP. And actually this code here was what Calum showed in October in Python, and Roy converted into R. So basically what this is doing, what we're doing here is we are defining in ERDDAP, in ERDDAP URL. So that's what this first line is doing, OSM underscore ERDDAP. And then there's the URL of the ERDDAP. And then in the second line, animals, the one that starts with animals, but we're using the ED search function to basically look for animals, look on this ERDDAP for any data set that has animals in the title. And we're saying that we want TableDAP data. That's what the which equals TableDAP. And then we're giving it the URL. And what it returns to us is it returns that there's a title of data on this URL that's called MEOP animal profiles. And the data set ID is MEOP underscore profiles. So, okay, we know that now there's some animal data on this ERDDAP. So that's what we're interested in. We wanted animal data. Now we're interested, well, what species are in this data set? So we're going to use the info function of our ERDDAP, and we give it the data set ID. So that's the MEOP profiles, and we give it the URL, which we previously defined. And then we return that into the data frame MEOP info. And then we extract the field that says species out of that, and then it gives us all of the species in there. So you can see that there's like about 30 different species that are actually in this data set. We have Wendell seal spelled in 3 different ways. This is part of the joys of working with data. That's not always consistent. There's a couple of elephant seals in there. One of the ways of spelling elephant seals is Southern Ellie, and that's a kind of cute name. So we're going to look at that one in a little bit more detail. So in the next slide, we're going to get the animal track data, the Southern elephant seals, Southern Ellie, using the TableDAP function of our ERDDAP. So in this call, we're calling TableDAP. We're giving in the info that we're getting, that we previously got from that data set. We tell it what fields we want. So in this case, we were going to want latitude, we're going to want longitude, we're going to want the time, we're going to want the species name. We specify the species name as Southern Ellie. We specify the longitude. We're saying we want longitude that's, in this case, we're just going to subtract a sector of the data. So we're going to a sector between 60 and 90 degrees east. So we're less than 90 degrees and bigger than 60. All of it less than 60 degrees. So basically, and this is 60 degrees south. And then lastly, we say the URL of the ERDDAP that we're getting this from. Then we just look at the return data, and we can see that we have latitude, we have longitude, we have time, and then the species. These should all be the same, and they are the Southern elephant seal. Note that the data that's returned from here is in our characters. That's what the CHR is in this in the data returned here. So we're going to have to convert that into numerical format if we want to, do other things with the data set. So in this next slide, we will do that. So the first lines of code here are just converting the latitude and the longitude into numerics, doing the same thing with the date, using a function in lubridate, using the lubridate package to do that. And then here, we're just going to add a factor of the year. We're going to convert from the date, the year, so that we can just plot the data showing the different years of the data. Next, just to make a quick plot, and here we're going to make a plot in ggplot. We set up some boundaries for the map. We get shoreline data with the call from map data, and then we make a plot using ggplot. So, and you can see the result of that plot on the right here. So basically, there's a lot of data in here, and we've used the year factor to color the data just to make it a little bit more interesting. So you can see that there's, the distribution of data from the different years. And as I said before, this is almost exactly the example that Caleb showed in October, only here we're doing it in R rather than in Python. So next, what I want to talk about a little bit more is I'm going to talk about the packages that use the Extracto packages. And basically, these are the ones that use the gridded, that really focus on the gridded data sets. What I've shown here is, I said I wasn't going to talk too much about, the fundamentals of ERDDAP, assuming everybody knows this. This is an example I use a lot when I'm talking about ERDDAP. and the ERDDAP URL. This is a gridded data set that looks at sea surface temperature, specifically in the Pacific. I use this a lot when I'm talking about the looking at temperature anomalies, because this data set also has an anomaly, and so you can see it. And so what we're going to do next is I'm going to look at this data set and look at it extracted in a couple of different ways. So first, I'm going to do it with the base commands. I'll see this a lot, that people will, this is the sort of fundamental way that one can get data from ERDDAP. So if you have the URL, which is the URL I just showed in that previous slide, you can put that in. You can use download file. You can say it's a netcdf file. You can then open up that netcdf file. You can extract it, trying to remember how you do that with netcdf file, and sort of, do this the hard way. Then you close the netcdf file, remove the netcdf file. So this will work. And, this is the sort of basic way of doing it. If you get anything wrong in this URL, it's not going to work. And you have to fiddle around with netcdf files, etc. So just the sort of cumbersome nature of doing this is why our ERDDAP was developed, so that you don't have to do this. It's all you have to sort of know is the basic information in that URL, which is things like the base URL, the dataset name, and the constraints on the latitude, longitude, or time. So to show that with our ERDDAP, first you obviously have to install the package. You are going to use the info data set that we showed earlier with our ERDDAP to basically get the basic information about that data set. So you do need to know the URL of the data set you're interested in, which we show here as CoastWatch, pfeg.noaa.gov, ERDDAP. And then the NOAA DHW monthly is the data set ID. So basically you're just saying, get me the information on this data set. And then using the GridDAP data, and again, this is from our ERDDAP package. You basically say the field that you want, you give the latitude and longitude constraints and the time constraints. And so what this will return to you is basically a chunk of data. In the command here, you can see I'm asking to see what's in that data that was just returned, and you can see that it's a data frame. There's actually, back up. The data that's actually returned by this data2 command is actually in list format. So it has the data, it has the data set metadata. So there's actually a lot of information that's in there. But the extracted data itself is in the data2 in a different, in a variable called data within there. So in this last call, what I'm doing is I'm looking at this variable that's contained within there. And so, and you can see here that the latitude and the longitude and the time and the sea surface temperature are within this variable called data that's within the data, the main variable that I called. And then note that time is in a character form, so it's going to have to be converted to a time format. The other thing to note here is that the latitude and longitude, you can see that they're very long vectors, as is the sea surface temperature, which is also in numerical form. So basically, this extracted data is what we call melted form. So the data is not in an array. So this is a different format than we're going to actually get with the other packages. So that's an important thing to keep in mind. So why did I have this in here now? This is basically just getting into a little bit more of the info function, which is used by the ERDDAP package. And this is just showing you what's actually returned when you call info on a data set. So here we're calling info on that this sea surface temperature data set. And if we look at what's returned by that, it's telling you the base URL, it's telling you the type of data set. In this case, it's a gridded data set. it's giving you the dimensions, both the time and the latitude and longitude, and then the variables that are in there. So in this case, there's actually 3 variables in there. There's the mask, and there's the sea surface temperature, and then there's a sea surface temperature anomaly. Now I'm going to go and talk a little bit more. I'm going to talk about our ERDDAP Extracto, which is another way of getting gridded data sets that, as I said, it uses our ERDDAP, but it extracts the data in a slightly different way. So we're going to download the same data set. First, we're going to install the our ERDDAP Extracto package. We're going to use that same call of getting the data info, calling that info command. And then we are going to extract the data using our Extracto 3D. So this is calling it slightly differently, but we're giving it the data info. We're giving it the parameters we want, sea surface temperature. We're giving it the latitude, the longitude, and the time coordinates that we want. And note here that the arguments that are used by our ERDDAP Extracto are different than the argument names used by our ERDDAP. So in the Extracto commands, we're calling Y chord, X chord, T chord, whereas in the function, our ERDDAP function, they were latitude, longitude, time. So slight confusion there, but you know, if you do a help on any of these variables, it'll tell you the parameter names that they, the field names that they want. And now the difference here is that the data is returned unmelted, and the data that's returned is just the data. So it doesn't have all that metadata and a lot of the other information that was returned by our ERDDAP call. So here we see that there's sea surface temperature. You can see it's in an array. We have latitude and longitude. These are in numerical format. And we have time. And we can see here that time has been, is returned in time format. It's not character format. So we don't have to convert that. So that's, again, that's a slight difference of how this data is returned. Now what we're going to do is we're going to use that our extractagon function in our ERDDAP Extracto. Remember I said it can extract a polygon. So if you don't want just a box of data. So in this case, what we're going to do is we're just going to define the coordinates of a shape. And so the easiest way to do that is I'm just using, basic trigonometry to define a circle. And so that's what I'm putting into X chord and Y chord here. I'm just defining a circle. This is going to be a circle that's focused on the equator and at 120 degrees west. So I'm basically making 15 points that are going to define a circle. That's what I'm doing here with the X, Y, and the Y chord commands. And then I'm calling our extractagon. I'm putting in the parameter name that's in the same data set that we've been using that's has the info contained in data info. X chord and Y chord I've just defined above. And then for time, I'm putting in basically that I want data from the date that I want the data from. So this is going to return, in this case, since it's monthly, it's going to return 3 months of data. And then I use the plot VBox to make a quick plot of that data. And you can see that basically it's returned the data in a circle defined by the X coordinate and Y coordinates that I input into it. Then next, we're going to look at the R extracto function. And as I said, this was sort of the primary one that these packages were first built on. And what this does is this is going to take the vectors of longitude and latitude and time to get statistics of gridded data in a small box around those points. And I said this was the purpose of this was there's a lot of people in fisheries who they put a tag on a penguin or an elephant seal, and then they want to get the satellite data associated with that. But it could also be a ship. Maybe you're out, doing a cruise, and you want to get the satellite data associated with the times you were in station. And so you have the vectors of X and Y and T. You give it the data set of the satellite data that you're interested in. And you also give it an X length and Y length. And what that is that's how big of the box that you want around that point that you want to average the points over. This can be a scalar, which means it's always going to be the same, or they can be a vector. The reason for this is that maybe with the tag data, maybe your resolution isn't always as the what's what I'm looking for. The estimate isn't as good maybe always, and so maybe you want the box bigger or smaller depending on the how sure you are about that data value. But in this case, we're just going to use a scalar value, and so we're going to extract sea surface temperature around the same x chord and y chord. Now, in this case, we have just defined x chord and y chord as that circle in the previous example. So basically, what this is going to do is this is going to get data for those circular points that we defined in the previous example. When we run that extracto, what does it actually return? It returns a list of, as I said, the statistics around those points. So the main thing we're really interested in is the mean sea surface temperature. That's called mean sea surface temperature in this list. But it also returns the standard deviation. It returns the n, so that is how many data points actually went into creating those values. It gives you the date associated with the satellite data for that value. And then it gives you the latitude, the longitude minimum and maximum, the latitude minimum maximum, the Z minimum and maximum, because you can actually sometimes, like, it can be model data, there can be a Z fact, a Z coordinate, but we're not using that here. The requested date, and then the median sea surface temperature and the median absolute deviation. So it gives you a lot of information. Most people are just interested in that mean value. Then we can very quickly make a plot of that by using the plot track function. So this is we're gonna give it as the input, the data that we just extracted in the previous call, the X chord, the Y chord, the T chord that went into that, a size. In this case, I just made the size 3. We're gonna say that we wanna animate it, and we wanna do a cumulative. So we wanna show all the previous points. So you can see it's just these circles going around a point. Imagine this was a tagged animal or something. As the animal is moving, it's getting the sea surface temperature from that spot in time, and then it's just plotting it. So that's what this function does. And the plot track is a really nice way to very quickly, make an animation of this, which is sometimes not the most easiest thing to figure out how to do. So it's very nice that function is in there to very easily show that. Now, as I mentioned, we've been doing, Coast Watch has been doing trainings for satellite data for a long time. We've created a lot of different tutorials of how to use these functions, with some examples. And we have these all on GitHub. Most of these we have not just R, but we also have Python code. So you can see here we have, I don't know, almost a dozen different examples. The names are fairly self-explanatory. On the next couple of slides, I'm just going to kind of walk through each of these and kind of show you what each of these tutorials does, and kind of what it shows you. And again, all of these are available on GitHub if you're interested in looking at them. This is just more information about each of these, but I'm going to walk through most of these, so I won't spend too much time here. So we have one. The tutorial one is the basics, and this is actually just showing people how to work with netcdf files. So this doesn't use any of those special packages, but it just shows you how to locate a satellite product in ERDDAP, and use that URL to basically download that data. In this case, it's looking at sea surface temperature. It makes a map of it. It makes a time series. This is one time series compare sensors. This is one we use a lot with people with using satellite data. If you use ocean color data, it can be very frustrating because in terms of looking at a time series going all the way back to 1997, you have to plot data from different sensors, overlay them, see how they compare. There is now a OCCCI data set that actually merges data from all of those different sensors. So you have one continuous time series. And this notebook basically does all of that for you. It shows you how to do that. You basically define an area of interest. In this case, the tutorial makes it for a little box in Gulf of Mexico, but you could do it for any place you wanted. And what it does is it basically gets data from CWIFs, which started in 1997. Then it gets data from MODIS, and then it gets data from VIIRS, and then it gets data from the OCCCI, and it plots them all together. And that's what we're seeing on that figure there. So you can compare how these different satellite products compare to one another when they're overlapped in time, and then so it makes that figure, and then it also makes average maps of each of the variables and time series. So it's a really nice intro to kind of seeing how to get data and do some manipulation with it and comparison of data sets. We have one that calculates sea ice extent. So this gets data from the PolaWatch ERDDAP. This is data that's actually, it's not in geographical projections. So you can see here on the map, the coordinates here are X grid and Y grid. These are actually in meters. So it's working with data that's not in your normal geographical projection. And then does some computing of sea ice area and extent. So it makes a map, it makes a time series of ice area and sea ice extent. And the intent with all of these is to sort of show people some, things that in the classes have come up that people want to do. And then it's just, hopefully you can find something that's similar to what you want to do and just use it as a starting point and convert it, to whatever it is that you want to do. The next example we have is creating a virtual buoy with satellite data. So this gets data from satellite data and from buoy data. So it actually gets data from using TableDAP and using GridDAP. So it matches up the buoy data to satellite data. And that's what this figure down in the right is showing, is a comparison of the buoy data and the satellite data. This was driven by somebody came to one of our classes. They had a buoy that was no longer being funded. And so they were wondering if satellite data could be used sort of as virtual buoy since they no longer had that buoy data. And so doing this sort of exercise showed that, yes, actually the satellite data can be used in this case as a replacement for that buoy that was no longer funded. This is just our example that shows how to extract satellite data within a boundary. I showed this previously with a circle. In this case, it's actually using a geographical region from the Longhurst sort of seascapes or Longhurst oceanographic provinces. So the boundaries of this area were put in, and this is the sea surface temperature for this area. This is the example doing the matching up of a turtle track to, in this case, chlorophyll data. Again, this is basically similar to the example I showed with the circle, only in this case doing it with actual turtle data, using that, matching up the chlorophyll data to the turtle data. We have a tutorial looking at working with data from with different projections. So it's basically having projected data and adding animal track data that's not in the same projection. So kind of helping people work with projections in. This is a matchup of satellite and buoy data, similar to the one we showed before with the visualizing the buoy, but in this case, we're visualizing the satellite data on a map well, the previous example was just looking at one buoy. This is looking at multiple buoys over the California current and looking at how the satellite data compares to an array of the buoy data. The other thing that we have a lot of times when people are working with the commands from our ERDDAP Extracto commands, they will get error messages. And the really cool thing about the functions in our ERDDAP Extracto is that the error messages are really helpful. And a big shout out to Roy for making that the case. But what I have found when working with people is that they don't actually bother to read them. And if you read them, they actually tell you what the error is and how to solve it. So what I put together is I put together this troubleshooting our ERDDAP extracto commands document. You know, a lot of times when you're looking for help on things, they tell you how you should call the form, you know, like they explain to you how it should be done, but they don't actually help you when you have a problem. So what I did in this document is I put together some of like what I thought were some of the most common errors that I've encountered when people use these functions. And so I purposely, you know, have it fail, and then I walk you through why it failed and what to do about it. So for just one of the examples here, you might get an error that the coordinates are out of bounds. But then it tells you, it says in this case, it says, okay, in data info, you're calling, in this case, it's a data set that's a chlorophyll data set. And so you can see the call that I've done here. I've called this data set. I've said the parameter name. I gave it the time coordinates, the X coordinates, the Y coordinates. But then it's telling me that the problem was in the dimension of time. And it says the given coordinate bounds are from February 2015 to April of 2016. But then it tells me, but the ERDDAP dataset bounds are from March of 2015 to 2021. And so then it tells you your coordinates are out of dataset bounds. So what this is saying is that I asked for data starting in February of 2015, but this data set didn't start until March of 2015. So it's not just going to say, oh, it's not just going to give you the data and not have data from February. It actually says, I can't do that. I cannot do what you asked me to do because you wanted data from February and I don't have any. So I'm just going to say, sorry, I can't do that. So all you have to do in this case is change your starting time coordinate to ask for data from March, and then it will be happy because it can do exactly what you wanted it to do. And so it will do that. But if it can't do it, then it's going to say, I'm sorry, I can't do that. So really, whenever you get one of these messages, just like read it, read it and figure out what it's telling you, because they are very explainable compared to, your usual R messages, which make, no sense whatsoever. The ones from our ERDDAP Extracto are very helpful. As I said, I walk you through a number of these in this document, and this is also on the CoastWatch training GitHub site. So just in summary, there's 3 primary libraries that are very useful if you're wanting to work with ERDDAP data on R. It's our ERDDAP, our ERDDAP Extracto, and then PlotDAP, which visualizes data. There's a number of GitHub resources. There's the CoastWatch training that I mentioned. The scripts that Roy converted from Rollo scripts are on Roy's GitHub site. And then iUse also has a code library. They're mostly in Python, but they do have some R examples. So you might want to check that out. And that's all I have. As I said, I do have all of the script commands that I showed in our studio, so I can run through that if people are, if you want to see that it actually works. But also feel free to, it's on GitHub, and you can download that notebook and try it for yourself. That's all I have.
Thank you, Kara. Just one question specific to the presentation, but for the recording, yes, the recording will be shared on the website that I shared in the chat, and the presentation can be found on the GitHub page. That's also in the chat. Well, if anyone has any questions, please raise your hand and I can unmute you. And there's one already. One second. Okay. You should be able to speak now, Clark, and ask your question.
I don't really know what happened. I didn't raise my hand.
Oh,
Hi, Clark.
Hi, how's it going, Kara? Nice to see you.
Yeah, nice to see you. How's it going with you?
Good.
Well, if anyone else has questions, please use the...
Roy's hand is up.
Awesome. You should be able to speak. Go ahead.
Yeah, I just wanted to say that the new version of our ERDDAP, the table dap now returns the units in the way they are in the original data set. So that won't come out as numbers, and
when did that come out?
I can't keep track of such things. You know that, Kara.
Oh, okay. I guess I'm not using the new version. I thought I had. Okay.
But yeah,
Update.
that was something that
Keep your libraries updated.
yeah, it was something while all this was being worked on that became obvious, something worth doing. So in the newest version, it returns the correct. Whatever the is shown in the ERDDAP is what it is, a character or an integer, or it returns the same thing.
Okay, great. So my presentation is already out of date.
Okay, now I actually do have a question.
Okay, great.
If that's okay.
Of course.
So Kara, as you know, I'm actually in Canada. We use a lot of NOAA data for various things, but we actually have quite a movement in the last few years to create our own Canadian Integrated Ocean Observation System, CIUS or CIUS, which I think the backbone for that is actually ERDDAP servers at a bunch of regional nodes to sort of distribute data. And I know when I was initially sort of starting to look into some of this, I ran into this issue with our ERDDAP. Maybe it's different now where its defaults are set to like NOAA ERDDAPs. And I guess my question is, and I think you may have shown an example of this, is it fairly easy to change the server that you're going to when you go out and call out with the info function and are trying to download data? And the second thing is a bit more general. I think it would be really nice to do some of these for specifically the CUS community who are kind of just starting to think about using these tools and servers now. So
yeah, so it is really easy, and I probably should have more clearly specified this, but when you call that info, there's just you call the URL, you say what URL you want, and then Roy, correct me if I'm wrong here, but I think that once you've done, like when you do that, it resets the default, so you don't like if you've made a call and you've said, the URL is this, then it saves that default. So I think the next time you call it, even if you don't put that in, it saves that as the default. Is that correct, Roy?
You can put it in either the commands allows you to put in the URL, but in our ERDDAP, if you pass the info value, that contains the new URL and it reads it from that value and uses that one. But
okay,
all the commands, all the commands
change?
allow you to add the URL, so there's always that option if you're unsure.
Yeah. Perfect. Thanks very
Yeah,
much. This is great. Yeah.
Yeah, and then in terms of your second question, I'm always happy to, talk to people about ERDDAP and using R or Python and so yeah, if you wanted me to talk to your the new consortium you're setting up,
Yep.
happy to help.
Okay. Good to know. I will pass that along. We might reach out. I mean, at the very least, these are recorded, I think,
Yes.
so that people can go back to them, which is fantastic. But it's also nice to have the live and interactive and tailor-made kind of thing too.
Definitely, yeah.
Right.
Awesome. Thank you for that question. We actually just had a meeting in Canada with Ocean Networks Canada, and we talked about CIUs with the OCG Observations Coordination Group. So it's all ringing a bell. Are there any other questions? If you do, please put them in the Q&A section or raise your hand. I don't see any raised hands anymore, which is fine. If there aren't any questions, then we can always let everyone go. Hold up, this wants something in the Q&A now. So it's off topic, but what is, was it difficult to get NOAA management buy-in to stand up ERDDAP servers for your data?
So, you know, ERDDAP was developed in NOAA. It was developed actually in the lab that Roy and I work for. So, you know, I guess in-house, we just sort of kind of did it. We're in the process now. I don't know. Roy, do you want to talk to this, Roy, or do you want me to bumble along?
I think it's best not to answer. And that's the answer right there.
Yeah, we can be a kind of more positive spin. You know, it has been, there are now, you know, ERDDAP first started in what was 2008. Roy, was that the first one? You know, there are now lots of ERDDAPs in different parts of NOAA, lots of IOS servers. So I think it is gaining a lot more. It certainly is much more widespread. I think much more respected and accepted than it was, like, say, 10 years ago.
I mean, don't know that
and
management
the point that, you know, we're having, you know, it depends on what part of management. But what has it been? It's on the list of, what is that? It's on the NOAA approved list of something or other. What is that list, Roy?
I don't remember the exact name. That's an old list. The main thing is I don't know that management has ever totally endorsed it, but a lot of people in NOAA that are interested in having data open and easily available have seen the value in ERDDAP and have implemented it, and therefore it's very pervasive throughout NOAA. But I don't know that's exactly the same as selling it to management. But if you want to know, it's in every IOS region, it's in every Coast Watch node, it's in a number of fisheries centers. It's more that people who really believe in open data and easy access have implemented it. So it's more from a bottom-up groundswell, and there's never been an edict that somebody has to do it. It's all been voluntary from people seeing the value of the service. And plus, Kevin O'Brien is a good salesman.
It's true. Yeah, I think, Peter, if you want to explore some of this, maybe it would be good to take this offline and loop in Kevin. Kevin's been really big in getting ERDDAP into the international sphere. So I think a conversation with Karen, Roy, and Kevin might be the best way. I just saw a hand up from Dr. Rao. If you still have your question, you can unmute and ask it. I see you unmuted yourself, but I don't hear anything.
Is it audible, madam?
Oh, now we can hear you. And
Hello.
hello?
Hello. Is it audible, madam?
I can sort of hear you now. Your microphone keeps disappearing, so I think it's having some trouble connecting, maybe. maybe type the question in the chat. Okay. Well, I don't currently see anything, but I did share Kara's email address. And if there's any follow-up questions, you can get in touch with me, and I'm happy to connect you with any of the presenters.
Hello.
Yeah, and yes, we can hear you.
Is it audible, madam?
Yeah, the audio is better.
Yeah. Thank you for your presentation, ma'am. It is very useful. So we are working on some Bay of Bengal temperature data. I hope you are understand what I'm saying.
Yes.
Yeah. See, there is some other sensors also like MODIS and Sentinel also providing temperature data. So NOAA is also giving temperature data. Ma'am, can you differentiate what is the major differentiator and what is the so these these R codes will be useful or any other platform to use to access data easily. This NOAA temperature data, ma'am.
So I'm not sure I understand. So you want to use temperature data. I'm not sure I understand the specific question. Can you rephrase it?
The first one is other sensors also providing temperature data.
Yeah.
NOAA also providing temperature data. What is the how we have to differentiate both of them, ma'am, and what is the major algorithm difference? So like, what is the major differentiation? And is it any other method to access easily to this NOAA temperature data, ma'am?
Okay, so so you're asking about Sentinel data. Sentinel is European sensors, much more. It's much higher resolution. We do have some Sentinel data. It is higher resolution, and so I'm not sure. I'm actually not sure about the temperature data. I mean, the thing, yes, there are a lot of different temperature products. And it's, in 1 or 2 minutes, one can't, summarize all the differences between them. But a lot, NOAA has temperature products that basically merge data sets from different platforms. The issue with really any satellite data, depending on how you're making the measurements, when you're making most of the well, if you make a measurement in the infrared in temperature, it can't see through clouds, so you have sporadic data. But you can make temperature measurements in the microwave, which can see through clouds. We can also make measurements on geostationary, which make measurements throughout the day. So NOAA has a number of products that merge these together for a sort of gapless. So in terms of like which temperature product to use, I mean, it's involved question because there are a lot of products out there. It really depends on what it is you're trying to do. For some applications, people don't want gaps. They can't deal with gappy data because of cloud. So they want a merged product that interpolates the holes and fills them in. For some people who are really looking at fine features, they don't want any interpolated data. So it's not a question you can easily answer. It really depends on what it is you're trying to do. And honestly, it might be easiest if you just contacted me offline, send me an email and maybe we can discuss this over email. But it really depends on, what it is you're trying to do to figure out what is the best product to use. And that's what we do at Coastwatch. We help people figure out what that is and help them get to the satellite product that's the best for them. So please just contact me online, kara.wilson@noaa.gov. I'd be happy to chat online or on email rather.
Thank you, ma'am. Thank you.
Emily just asked a question in the Q&A section saying, I'm curious about your decision to exclude the metadata from your pull through the extractor package. What is included in the original ERDDAP metadata?
Well, if you, in that the pull that gets from our ERDDAP, there's a lot of metadata. I didn't show that on the screen. I mean, if you basically do a list of what's in there, there is a lot of information. Personally, I find it's hard to find the data you actually got. So I find it more convenient the data that you get back from the ERDDAP extractor commands, because it's just the data. I mean, if you want the metadata, if you want all of that stuff, you can go and get it. It's, because you know where you got that data from. You know the data set ID, and you can go and get that data. But I find it much easier to have what I get back be just the data, and not have to sort of like search around for it in a lot of other stuff. Just different ways of doing things. Nothing's right or wrong.
Most of the metadata is contained in the info response. If you do a structure on it, if you do an str on the info and get the details, you'll find what Kara showed is what you get when you do the print, which is just a summary. But most of the metadata is actually in that info either way.
Fabulous. Thank you both. Thanks everyone for attending today's webinar. Again, we have a couple already planned for the next couple months, but the dates aren't quite set. They will be set and distributed within the next week, hopefully. We'll update the website to include the YouTube links, also from today's webinar, and you'll find all the links that Kara shared on the website as well. Just give us a day or two to adjust that online. I'm going to stop the recording now, and thanks everyone for attending.